covered in the last video the packaging and random forest, and today we'll focus on boosting. So it's the same principle. We try to train our data first with the weak learners, and then we combine multiple trees into a strong learner. So the difference with boosting, each new model tries to correct the error made by the previous one. So we try to build as much as trees, and each tree try to fix the error for the previous tree, and so it works as sequentially, one after one. And the goal of boosting, the main goal is to reduce bias and variance and improve predictive accuracy. So this is all the goal of the Ensemble learning techniques. We have three types of boosting. One is the gradient boosting, and this one we try simply by our first tree, and then we calculate the residuals. The residual is the difference between the predicted and the actual data and predicted one. And then in the second model, we train the second tree on the residuals of the first tree to remove all the errors, and then we continue until we count the at the final model. You'll have the summation of all trees. And the key points in here is we use a gradient descent to minimize a loss function step by step. We have AdaBoost. In AdaBoost, we will start with the first tree, and then we will add weights on the misclassified observation. So if you have predictors like the branches that is considered as a noise, so we add more weight, and then we come to the second tree and we add more weight, and at the final model we combined all the weight, and we combined all the weight from all the trees. So the key point in here, AdaBoost is assign more important weights to hard to classify point instead of residuals. And the previous one in the gradient one, we add the residuals, but in here we add more weights. We have XGBoost. This is totally different from these two, the extremely gradient boosting. So in here we use the regression. We add the lasso and L2 ridge. This is the penalties to avoid overfitting. So we discussed the lasso and ridge in the linear regression, how we use them to check to prevent the overfitting for a data. And parallelization can train trees in parallel much faster than traditional boosting. Handling miss values, XGBoost automatically handles missing value by learning the best direction. And also it can use as shrinkage, learning rate. After each tree, predict are scaled down, slightly controlled by eta, preventing overfit. So we use the learning rate to preventing the overfit. And if you use the low learning rate, so we will have the model gonna run faster than the slower, but the accuracy gonna be high. But if you use the high learning rate, the model will be running faster, but the accuracy gonna be high. So let's gonna do all these technique in the R Studio. First, we'll have to upload my CSV file, the same the one we used before, and we'll run this one. I'm gonna just clear everything so you can start. First, we have run our CSV file, and then in our CSV files we talked before, you have to check the summary if we have any missing value. So in here we have NA. This is empty value. We need to find the mean to cover this empty value, so we run this as we talked before. We run this talk function is.na to find all the missing values, and this is na.remove to remove the empty file, and then we calculate the mean for them. To run this one, and then okay, this is to check for missing value if it's already removed, and then we don't have 0, 0, we don't have any missing value. We have to split our data. We talked about that before multiple times, so we should use first, where's the CA tool? This is the packages. You need to CA tools to first to unpack this one, and then we go here to split our data. 80% for train and 20% for test. You need CA tools. So firstly, we're gonna start with the gradient boosting, and in here we need to install the package is called GMB. So GBM, sorry. So if you don't have GBM, just go for install and write in here GBM, and here we go. You will have the GBM, and then install it. You will have same as me in here. So the GBM function stand for is going to run the GBM function. Just the this is like marketing questions, and then GBM you will have this. You will have the help. We can see. So GBM it generalize boosted regression model. So this is all you need to. There's a formula we can remember, and we can check what is this one. This what for. So at the first model for boosting, I'm gonna just run for numerical data. So I use the collection my independent variables, and this is tilde and all for other my independent variables. So the function is GBM. We use a GBM to calculate my gradient boosting. This is my target variables, and this is my all the independent variables, the dot, and the train data is equal to train because I separate the data into the train and test, and we talk about that many times. So in here the distribution equal to Gaussian. So you came to the help, you check for distribution. It's used for depend on your purpose. So if my purpose in here to use the logistic, so I have a numerical data, so I should use the Gaussian. But if your purpose to only two unique value, so you should use instead of Gaussian, you should use this is Bernoulli. This Bernoulli is used for classification purpose. But since my classification purpose is regression and numerical data, I need to find the collection. So I use the Gaussian. And this is number of trees. So if you came in here, we check the number of trees. So this is integer specifying the total number of trees to fit. This is the total number of trees. The more total number of trees, so the more error calculated and the more error fixed, so you will have more accurate. And this is integrated depth equal to 4. So we have the where's the integrated depth? This one to create a specific the maximum depth for each tree. So this is the maximum depth for each tree. To split our data, this is only we set it for 4, so we don't need a complex tree. We need the maximum depth, so 4 in each sublet. This is shrinkage is 0.02. This is the learning rate. This is the learning rate and is from 0.1 usually work, but small learning rate typically require more trees. So it's recommended between 0.2 or 0.3. We should have fixed like low learning rate. And this is verbose is equal to false, and you can check the verbose as this is the logical, indicating whether or not to print out progress and perform indicated true. If this option is left and is specified for GBM more than it is verbose from object, the default is false. So this is how we run our first boosting. So and then we will test. We try to test our boosting on the test data. In here we just have to put this as a gradient boosting. This is my model. After I fitted my model, we try to predict my model on the test data and scene data 20%, and I use number of trees same as what I use in my model. And you check. So we have in test, and this is we have the mean square error. It is a mean square error is the mean. The test $sign boost. This one the predicted one, and minus the actual value for collections, all by the var square. So if we check the test here, I'm gonna go for test. We have in here this is the boost, the predicted value, and we have the collection in here. So we have 71,072 and 44,000. This is 45,000. You can check if it's perfectly or not. Okay, so this is the first method, and the main R square we have in here is this is main R square for both is 43,000. So 43,000 for the collection. And the second method we add, this is AdaBoosting. In the AdaBoosting we need to first unpack these packages. It's called Ada. So AdaBag is allow us these packages we need to unpack first. So in Ada packages I'm gonna do for Ada package I'm gonna do for classification purpose. Okay, so firstly I have to use another firstly for this I use the df equal to and I just name my CSV file as a df, and this is df. I have only 17 variables. I remove the 2 variables that is was for genera, and one for the something like we have yes and no value, and yes and no value, and someone will have genera drama something. So I have corrector. I remove the corrector because the first one I am focusing on numerical data, so I remove all the classification from my CSV file. At the second, so I'm focused on classification in Ada, so I called my CSV file df2. If I run my CSV file now, I was gonna check df2. So in df2 I have my this is 3D available, X 3D available yes and no, and also I have this this is genera, so thrilled drama company, and this is the comedy, and I have my star tech scar. This is like I need my independent variable that I will predict. So in here in df2 we did that the same. Firstly to check the missing value, and then we have to check for missing value if you have in here for missing value, so 0 0 don't have missing value. Then I have to split, but I'm gonna call it now train C for classification and test C for classification. So I have to run this one. I have to set my seed, and we talk about seed. So firstly I need to convert to factor. I need to start working on for my df2. If you second here, I have the start tech in here. I have the column in numeric with range 0 to 1. So in AdaBoosting I need to change the numeric 0 to 1 into the factor. So I need to change it first into two factor. I'm gonna run that. So this is training started tech Oscar. We need to start tech Oscar in our training data to convert it as a factor first. And after that you can select train C. Where is the train C? You can see now if you go for train C, this is column factor with 2 levels. So we change it to factor from numerical to vector because we needed to change it to categorical data like groups. And then we have the AdaBoost equal to, we use the boosting. This is function, and if you need to read more about boosting question mark, you will have the help function. So in the boosting function we have my independent variables. It is star tech Oscar, and I have my tilde and dot. This is for all my dependent variables. And data equal to train C I use to predict my model on the training data, and this is boost equal to true. So if we came in here, we read about the boost. If it's true, by default a boost SRAM sample of the training set is drawn using the weight for each observation on that rotation. So using the weight for each observation, and that we said in the Ada we used to weight, we add more weight on the predictors. so to avoid the overfitting and we have more accuracy. So that's why we use the boost equal to true to add the weight. And for we have, I'm going to run this one first. So now we have to predict ADA on. So predict, this is my AdaBoost, the fitted model, and I have to do it on the 20% test data. So I have to fit that, and then let me check the table. So this is for a classification. This is confusion matrix between my predicted class. So in ADA data, if we go to the after we predict ADA, this is ADA. Let me check predict ADA. I will show you. So in here we have in the predict ADA we have this is vote probe, we have a class. So I'm gonna focus on the class where the character is called 01. So that's why I use the predict ADA and add the class, because I need to check my confusion matrix with 0 and 1. This is test C start text. This is my real start text from the test data, and this is my predicted start text Oscar. And I got, if you can check in here, I have 0 is 13 correct and 41. So this is over like 71 accuracy. And for the last one we have XGBoost, the third model. First in XGBoost is kind of some complicated. I have to separate my training Y and test first. So this is my training Y and training X, and my test Y and training and test X. Separate them first. The first one, I need to convert the start text Oscar. I need to convert them from categorical into the false true. If we run this one, you can check I have my training one equal to true false, and then this is for, and I need to change my training X into the matrix. So because after that I need to use them at the matrix. So I have to change all my independent variables into matrix. I will do the same for the test. And here we go. Before we try our D8 matrix, I need to convert my true false data, the vector data into the binary data 0 1. So X matrix, for we use the XGDB matrix, and data equal to train X, the data equal to my train X, and the labels equal to train Y. This is train Y. So this is my X data and my Y data. I need to convert the true false data into the binary 0 1, so it's easy for the model D matrix is going to be much more faster, and it can easy to predict the data. And then X boosting, same, we can check. We use the D matrix to convert our true false data into binary data, so it will be so faster and will enhance the prediction. So first, but we need, I forget to tell you, need to, for XGBoost we should have unback. This is the XGBoost. So just click on that. You have to unback this first, and if you don't have XGBoost, just go for install, you will have it. So, and then this is gonna just XGBoost. I was gonna say, so we have the help function will help us to use to check. So XGBoost, this is the function that we use to store our fitting data for XGBoosting. I have data equal to X matrix. That's why we convert our data to X matrix, because the this is like GX books. They need to convert your input data into the matrix is depend on the train data, and the labels equal to train y as your independent variables. And number of rounds, this is the max number of boosting rotation. So you will define the max number of boosting rotation, and the objective equal to multi-sum, so the objective equal to multi softmax, and this is like multi softmax set XGBoost to do multi-class classification. So if the purpose to do multi-class classification, so the purpose I need to do classification, so I use the multi equal to multi softmax set. And if your purpose to do like this is survival for regression, and if your regression to do regression, so you can use the count Bayesian in here. So depend on your purpose, you can check the objective. And this is the eta, this is like the lambda that we use, the low lambda and high number of rounds. This is the low number, it give you more accurate and more fitted number. The number of a class, we set it to 2. We don't need too much classes because we only have number of classes to 2, 0 or 1, and we have the maximum depth equal to 100. With this is the maximum depth for our trees. We don't need too much more complicated depth, so the depth is 100, is very also big. So here we go, we have 15 in here. This is number of rounds, we have only 15, and after that we have to check we have to XG predict. So we predict the data and we check our predicted data. And now if we're gonna upload the confusion matrix, so we have like 41 and 27, so this is 18, this is 68 accuracy. So we have 27 false and 41 as a true. This is the accuracy is like 80. This is 68 accuracy. Is much more better than the AdaBoost. And this is all you need to know about how to build your boosting technique. Please subscribe and leave me any comment, and see you in the next video. Thank you.